Hi everybody, you just watched a video on how the complex numbers have zeros that come in conjugate pairs, and I want to use this example, use those same zeros that we found that would be for a fifth degree polynomial to come up with the actual equation. And so what we're going to do is we're going to start by finding the factors, or write our zeros as factors, and then multiply and get the polynomial in its standard form. So we'll have x plus, x minus 1, because when you set that factor equal to 0, you'll get x equals 1. We'll have x minus 5i and x minus negative 5i, so it'll be 5i. And we'll also have x minus 1 plus I and x minus, and let's put this in parentheses here, x minus 1 minus I. Alright, so this is going to be our polynomial in its factored form. We want to start to simplify this and writing it in a way that's going to be in its standard form. So we can simplify this by writing it as x squared minus 25i squared. So you have the difference of perfect squares here, and so all you need to do is multiply the x's and the 5i, square the 5i, and it's negative here. We'll take care of the I squared in a moment. I'm going to rewrite this. I'm going to distribute the negative in each case. And so we'll have x minus 1 minus I, and I'll have x minus 1 plus I. Alright. And the way that I want to think about this part now is I want to think about this as the thing together. And so the reason is that now we'll have that difference of perfect squares again. You have that same quantity in the parentheses and then conjugates here, so opposites here. So then now we can apply the difference of perfect squares when we multiply that. So we'll end up with x minus 1 times x squared. I squared is defined as negative 1, so plus 25 equal times, this will be x minus 1 squared minus I squared, and then I squared is negative 1, so it's going to be plus 1. We can then multiply this out. We'll have x minus 1 times x squared plus 25 times x squared minus 2x plus 1 plus 1. So then let's make that 2. And this is kind of the annoying part for these homework problems, is that we now have to go ahead and multiply all this out. So I'm going to have x cubed, doesn't quite look like a 3, x cubed plus 25, let's do the minus x squared first, and then plus 25x minus 25. And all of this is going to get multiplied to x squared minus 2x plus 2. Alright, let's clear the page and start from there. Alright, so we want to multiply this out. I'm going to end up with x to the 5th minus 2x to the 4th plus 2x cubed minus x to the fourth plus 2x cubed minus 2x squared. Let's just carry down here, so then we can maybe line things up a little bit more. And what is this one here? Was it x to the fifth? No, 2x to minus 2x to the fourth plus 2x cubed minus 2l. This was the minus x to the fourth. Alright, so we're going to be at 25x cubed. Let's put it here. Minus 50x squared. And plus 50x. And the last one is minus 2x squared plus 4x minus 4. So when we combine everything, we'll end up with x to the fifth, negative 2x to the fourth minus x to the fourth is negative 3 x to the fourth. Let's get some little typos here. And when we continue on, let's see, 2x cubed plus 2x cubed is 4 plus 25 plus 29 x cubed. Then negative 54 x to the second. And plus 54x minus 4. Alright, so this is our polynomial. And I think the key to this part is when it comes to doing the multiplication, the key is to think about this part as x minus 1 plus I. That's one factor, and then the other factor is x minus 1 minus I. And so once you distribute the negatives through each of these, you look at this as x minus 1, and then use your difference of perfect squares to go ahead and proceed to simplify, to do the multiplication. Alright, I hope you found this helpful, and I'll see you in another video.